Hello, algebra students. Mr. Lawrence here, and this is going to be a review video for the test we're going to have either on Wednesday or Thursday. And we're going to say I can add and subtract polynomials, I can FOIL, I can factor, and also I can solve quadratic equations by factoring. All right, so let's get down to it. Now, remember on that quiz we had a couple weeks ago, a lot of you were goofing up problems like this. They are very simple. This is not a multiplication problem. Look, there's a plus sign smack dab in the middle. It can't be multiplication. So all I'm going to do is add my like terms together. So those are my x to the fourth terms. Here are my x squared terms, making sure to grab the signs. I have some plain old x terms, and then I have some constants, some numbers without variables. All I'm going to do is combine them. So if I combine my yellow ones, I believe I'll get 8x to the fourth, right? There's 6x to the fourths, and there's 2 more of them, so I have 8 altogether. My green ones, looks like I'm going to have a negative 4x squareds. My blue ones, there's only 1, so I just bring him down. And then my magenta ones are plus 1. If you're having trouble with that, you need to come in and see me. It is too easy to get wrong. Okay, here's one that a lot of you get wrong because you forget what to do with the negative. See that negative smack in the middle? We need to distribute him. So we're going to go change them to a plus and multiply by negative 1 all the way through the quantity. Every term is going to change signs. Now I'll go ahead and highlight. Okay, and there's some x cubed term there, and there's x cubed there. I have x squared and a minus 4x squared there. Here I have a plain old 2x and a 6x. And then I'm out of colors, so I'll pick a new one. And there's a negative 9. Now all I have to do is put the magenta ones together to get 18x to the cube. X to the third, excuse me. My yellow ones will give me a negative 8x squared. My green ones will give me a plus 8x. My light blue ones will give me a negative 9. And that's how simple it is. I cannot put these together because they're not like terms. The exponents don't match. Okay, let's check out the multiplication. Problem number 3 and 4 are distribution problems. All I'm going to do is multiply the 2x times those terms. So 2 times 5 is 10. X times x is x squared. 2 times 6 is 12. The x comes along for the ride. I am done. Please don't make this difficult. Same thing here. I'm going to take 3x to the fourth and I'm going to multiply it by 4x to the fifth, negative 2x cubed, and by a positive x. So negative 3 times 4 is negative 12. X to the fourth times x to the fifth, x to the ninth. Negative 3 times negative 2, positive 6. X to the fourth times x to the third, x to the seventh. And there's a 1 in front of there. Negative 3 times 1, negative 3. X to the fourth times x, x to the fifth. Some of you were thinking that was x to the fourth there. You are incorrect. Problems 5 and 6 are FOIL problems. A lot of you don't recognize 6 as a FOIL problem, but let's do 5 first. So I'm going to go first, outer, inner, and lasts. The first terms of my quantities are 7x and 2x, which gives me a 14x squared. My outer terms are 7x and negative 3, which gives me a negative 21x. My inners are a negative 6 and a 2x, negative 12x. My lasts are a negative 6 and a 3. They give me a negative 18. Oops, I'm not sure what that is, but it should be an 18. Now I'm going to combine like terms. These two are like terms. So I'm going to get 14x squared minus 33x minus 18. And there you go. Now I can prove to you that this is a FOIL problem. See that 2 there, the exponent? Doesn't that mean that there are 2 quantities of x plus 5? And there you go, it looks just like a FOIL problem. So x times x is x squared. Inners get me 5x. Outers get me 5x. Last get me 25. The answer is going to be x squared plus 10x plus 25. Not sure where my 5 went there. Apologize, my voice is going in and out on me. All right. Now, for these problems, we're not actually going to do them. Take a look at them. Look at problem number 7 in black there. See if you can tell what type of factoring was used. Well, I had a binomial. It's a perfect square minus a perfect square. That must be the difference of perfect squares. Problem 8, I have a trinomial. Lead coefficient was 1. There we go. 16x squared minus 4x plus 25. It's a trinomial. 16x squared is a perfect square. 25 is a perfect square. Looks like that's a perfect square trinomial. Let me test it and make sure. Square root of that would be what? 4x. Square root of that is 5. 4x times 5 is 20. Doubled is 40. Yep, it's a perfect square trinomial. Okay. This one here, a trinomial. Lead coefficient's not 1. No perfect squares. That must be the one they do by grouping, where we rewrite it as a polynomial with 4 terms. Let's see what happened here. 1, 2, 3, 4 terms. It must be grouping. And I think the last one, let's see, 5x to the 4th y squared minus 5x cubed y. And then they've got this thing out front of a quantity and xy minus 1 left. Looks like they GCF'd it. Okay, just some quick examples of which type of factoring to use. Now we're actually going to use them. We're going to come down here and we're going to do some factoring. All right, I've got a trinomial. First thing I always check for is a GCF. I do see a GCF. For the coefficients, I see a 2. For the a's, I see an a squared. And for the y's, I see a y. So I'm going to divide everything by 2a squared y. 2a squared y. GCF comes out front. Times, those are gone. Those are gone. A to the 4th over a squared is a squared. Minus 4 divided by 2 is 2. A cubed divided by a squared is a. Y squared divided by y is y. Coming to last term, 8 divided by 2, 4. A squareds cancel, y's cancel. There we go. Looking inside here, this will not factor. I am done. It was a straight GCF problem. Okay, 14. It's a grouping problem, but because there are 4 terms, but I don't like the order it's in. I think I'm going to rewrite it as 2m squared plus 3m minus 10m minus 15 for GCF of the first group. And look for a GCF of the second group. So I don't believe my GCF of the first group is correct. I believe it's just going to be m. Pull an m out, and I'll have 2m plus 3. And here I think it's 5, only I notice they're both negative, so I'm going to pull out a negative 5. Be left with a 2m plus a 3. One more GCF to go. 2m plus 3 is quantity times m minus 5. And we're all done. Okay, now we're going to do some factoring and actually solving. So I have 15, I have a binomial. It's a perfect square minus a perfect square. Let me just double check. 9x. 1. Yep. So it's going to factor as 9x plus 1. It's quantity of 9x minus 1. But since it equals 0, I've got to solve each part. 9x plus 1 equals 0. Subtract 1. Get 9x equals negative 1. Divide by 9, divide by 9. x equals negative 1/9. Then I have to do 9x minus 1 equals 0. Add 1 to each side. 9x equals 1, divide by 9, divide by 9. X equals 1/9. There are my two answers, positive and negative 1/9. It won't always be that way, it's just that way in that problem. All right, 16, it's a trinomial. Looks like I got a perfect square there, 3x. Perfect square there is 2, multiply them, 6x double, 12. We got a perfect square trinomial. 3x minus 2 times 3x minus 2. I'll solve 3x minus 2 equals 0. Add 2 to each side. 3x equals 2. Divide by 3, divide by 3. X is going to equal 2/3. I don't need to go and solve this one because it's the same exact quantity. I'll get the same exact answer. Okay, 2 more trinomials. 4 more trinomials. Let's see here, c squared minus 8c plus 15. Trinomial with a lead coefficient of 1. So I'm going to list the factors of just the last term, 15. Since there's a plus in the back, I'm going to add to get 8. Well, that would be 3 and 5. And remember, that plus in the back means a Wendy's double stack. So it's going to look like this. They're both going to be negative, and I'm going to use 3 and 5 to get 8. Solving will get me c equals 3 and c equals 5. And there are your two answers. All right, let's come over to number 18. Same type of problem. Going to list the factors of 32, 2 and 16, 4 and 8. 6 doesn't go in, 7 doesn't go in, that's it. Since there's a negative here, I need to subtract to get negative 4. Looks like 4 minus 8 will do it. So I'm going to go x plus a 4 and x minus an 8. And there you go. Again, I got to solve. X plus 4 equals 0. X is going to equal negative 4. X minus 8 equals 0. X is going to equal 8. All right. Last two. Got a trinomial here. Lead coefficient's not 1. Don't have any perfect squares. I'm going to multiply 6 times 14. Well, if I triple 14, I get 42, and double is 84. So I'm going to list the factors of 84. 2 and 42. 3 is going to go in 28 times, I think. 4 is going to go in 21 times. 5 is not going to go in. 6 should go in. 6 and 14. It had to be because that's what I multiplied together. 7's not going to go in. 8's not going to, oh wait, 7 might go in there. Yeah, 7 is going to go in 12 times. 8's not going to go in. 9's not going to go in. 10 won't. 11 won't, and I'm done. So I need to add to get 25. Looks like these two will add to get 25. So I'm going to rewrite this as a 4-term polynomial. Let's see here. Well, I want them both to be negative. 4x minus 21x plus 14. I'm going to do my grouping now. Notice I grab those negatives. Looks like my GCF is 2x. And here it looks like the GCF is 7, only I have a positive, then a negative, then I have a negative and a positive. So I'm actually going to GCF a negative 7 so that my signs match up. Negative 7 times the quantity of x minus 2, 3x minus 2, excuse me, equals 0. One more GCF, I'll get 3x minus 2 times the quantity of 2x minus 7 equals 0. Now I'll solve. 3x minus 2 equals 0. Add 2 to both sides. I'll get 3x equals 2. Divide by 3. And I'll get x equals 2/3. Over here, 2x minus 7 equals 0. 2x equals 7. Divide by 2, divide by 2. X is going to equal 7 over 2, or 3.5. And there's your two solutions. Okay, one last problem. Trinomial. You know what? Before I do anything, I notice there's a GCF here. You know, especially if I remember to put the x on the squared on the last term. There we go, like that. Sorry. There is a GCF now. It's 2x. So I'm going to factor out that 2x. I'll have x squared plus 9x plus 14 equals 0. Now this 2x is going to keep coming down for the ride. I know that 14, the factors are 2 and 7, 1 and 14. I'm adding to get 9. Well, 2 and 7 will do that. So it's going to factor like this. And then I'm going to solve each piece. There will be 3 pieces to solve. So the first solution is x equals 0. The next solution will be x equals negative 2. And finally, the last solution should be x equals negative 7. And there you go. That's it for the video. My voice held out. There won't be another video for review, but you can check this one and check out problems, and we'll be spending time in class. All right, Mr. Lawrence signing off. Have a good night, everybody.